Hello everyone and welcome to another episode of All Things IDA. In this episode I'm going to be talking about IDAPython as a plugin, how it works, its files, how to configure it, and just enough information to make you comfortable about this project. Now the goal of these IDAPython series, since this is the first episode, is to get the introduction out of the way, and going forward we will be exploring various topics in IDAPython. Having said that, let's get started. Quickly, a brief history about IDAPython. As far as I know, IDAPython first emerged around 2004 by Gergerly. He made it as a plugin and shared with Hexrays until around 2009. He didn't have enough time to maintain the project, so I stepped up. I used to work at Hexrays back then. I stepped up and started maintaining the project fully. That's where I did a big revamp, lots of cleaning up, speed ups. And then when I left Hexrays around end of 2011, Arnaud from Hexrays to this date still is doing a great job maintaining IDAPython fully. It's worthwhile mentioning around 2013, a guy called Einstein. I remember meeting him in Recon 2013 or so, and he also contributed wrappers for the decompiler. So it was unofficial wrappers for the decompiler. And then slowly Hexray started to maintain those wrappers and also made them clean and robust, and now they're like officially also part of the IDAPython project. Having said that, I think you know by now that IDAPython is an open source project, and you can contribute to it, even read and learn from its source code. So the first thing is let's take a quick look at the file system where we installed IDA and look at the IDAPython files. So when we install IDA, in my case, I installed it in my tools folder. In your case, could be program files. In my case, just tools, IDA. And if we look at that directory, we'll find a few things related to IDAPython. The first thing we can observe here in the root directory is there's a utility called IDAPython switch. I'm not sure if you're aware of it, but this is an important script. If you run it, it's an important program. If you run it, it lets you choose which version of Python you want to work with. So IDAPython is not hard-coded to work with specific Python version, so nicely we can dynamically switch which Python version we want to work with. So here it picked my latest installation at 0, which is basically designated 3.11. This version 3.9.7 comes with Visual Studio 2022. So that's the first tool, very handy. If you're not aware of it, this tool is available on Linux, Mac, and Windows. It lets you switch the working Python for your IDAPython plugin. Apart from the IDAPython switch tool, we have the Python folder inside IDA installation. We have a couple things. We have examples. Examples is really comprehensive. Of course, you can have thousands of examples, but it has enough examples. We have close to 86 examples organized nicely. We have stuff related to analysis, debugging examples, app call, debugging hooks, decompiler examples. We have here VDS. These are direct port of the SDK C++ version of the plugin. So this is for the examples, various examples working with forms and so on. And then the folder 3. Now 3 means Python 3. Back in older versions of IDA, we used to have 3 and 2. So we could support Python 2.x and 3.x. Now, what do we have here? So the first thing we will notice here as well, let's get it out of the way real quick, are those IDA underscore files. Those files come directly from the SWIG generator. They correspond to the SDK includes. So if we go back to the SDK here on the left and in the includes folder and take a look here at the includes, we have all those header files. These are the header files you would normally work with when developing a C++ plugin for IDA. And in IDAPython, in order to expose this functionality from the headers from the C++ SDK, we need to write a wrapper using the CPython API. So if we can actually wrap every single C++ function and introduce it to the Python environment, then we have like added Python support. If we want to do that by hand, it will take forever. So in IDAPython, we use SWIG. So SWIG is just an open source software. It lets us basically connect programs written in C with other higher level languages or scripting languages. And we can basically generate glue code or wrappers for the C++ SDK into Python. Then the IDAPython plugin would be a simple Python host that embeds the Python API and lets us run scripts and so on. So going back to those header files, so these are the SDK files, and those are the generated files corresponding to the header files. So if we take a look at one file, we will notice that we'll see SWIG and so on. This is mainly auto-generated. It's not handwritten. Of course, there are some stuff we had to manually inject into this file. SWIG lets you inject stuff in addition to having it fully auto-generate. So normally we don't have to really look at that file since it's automatically generated. But what we see here, all those stuff here are found in the SDK. So here, if we are in ida_funcs.py and open, for example, funcs.hpp, which is the counterpart, and look for, let's say, get current IDA signature here. So that's the HPP file we opened, and we can see is the same function being automatically wrapped into a Python API. So these are all the IDA underscore files. Now after the IDA underscore files, we have the IDA API file. Let's take a look at what's in IDA API. Now, IDA API itself is not auto-generated. It used to be in the past where we did not have those individual IDA underscore. We had just idaPy.py, which included everything. It was a very, very big file. Now to speed up building IDA and generating Python wrappers and whatnot, it has been split. So we split every header into its own wrapper. Like this, if we change one header file, we don't have to generate a huge Python module. So that's just for being clean and also speed up generation of the wrappers. So IDAPython API file or module simply imports everything that have been auto-generated. So like this, we don't have to import individual modules. Say we want to work with cross-references, we don't have to say import IDA_xref. We can equally simply say import IDA API. And so here, as you can see, all those are included for us. So you might see me writing scripts where I simply include IDA API and nothing more. Also, IDA API exposes the cvars global variable. This is used to access global variables. IDA SDK does have global variables that we can access, and they're exposed through idaAPI.cvar. So this is for IDA API. Simply, if you're writing a hello world script, import IDA API and start using the SDK. Now, IDA API is the lowest API access. It's directly mapped to the SDK itself. In IDAPython, we have some higher level facilities, so we're kind of one layer of separation from the SDK. That's where let's take a look first at idc.py. idc.py is a compatibility module for the IDC language. Now, if you don't know what's IDC language, also let's go back to IDA installation folder. So going back to IDA, inside IDC, we have a bunch of scripts, and these are IDC scripts. So IDC is the built-in language that IDA understands. And idc.idc is the header file that you include from your IDC scripts in order to call IDA functions. So looking at idc.idc, this idc.idc contains all the IDC methods that we can call from scripting. And here they are divided by category in the same file. So like miscellaneous functions. Let's search for another class of functions, for example, objects, get attributes, has attribute, loader input class functionality, changing program representation, segment deletion, making instructions, generating output files programmatically through the gen file IDC method, information API, global settings, UI, and so on. So IDC, if you have used IDA since a long time ago, before IDAPython was available, you must have used IDC. And so if you want to switch from IDC to Python, you have to learn the Python language. And the second step would be to learn the actual IDA APIs. Now, if you used IDC before, then if you use idc.py, you should have the same functions and same arguments and same behavior, but in Python instead of IDC. So let's switch here back to idc.py. So idc.py, being a compatibility module, will replicate all functions found in IDC actual language. So this is for idc.py. All right, we can take a look at idautils, and finally we'll look at the init script. So idautils as well is not a compatibility module. It's simply a utility module that might use IDC, might use IDAPython, but its goal is to make the interfacing with IDA SDK as Pythonic as possible. So for example, we try to use generators when possible. So let's say we want to enumerate a list of names. If we are to use the SDK, we'll have to do a bunch of calls. Like we have to get the function, get the list of names. How many names are there? Then we'll have to enumerate and retrieve every single name EA by index, and then get the name by index. So here we have a simple generator that conveniently returns two pieces of information that make sense for us. So here, if we're in the Wizmo program database, just the database I'm using for testing, and I use the script command just to open this window and import idautils and do this small loop, I can, let's press Alt-R to run it. You can see it's a very convenient way to basically enumerate all the names from the names window. So here we got the same list, but programmatically. If we wanted to achieve this without using idautils, we would have to replicate individual, like at least repeat this loop and call 3 individual APIs. So idautils is very handy. I would say take a look first if it has the function you need inside it, and then use it. Another important utilities we can get from idautils, I would say, is the CPU helper. Real quick, show you the CPU, what it does. So I'm gonna, let's switch debugger here. And just start the debugger real quick. And here, if we, okay, let's create a quick script and say import idautils and print the value of EAX is idautils.cpu.eax. We can do that, and that's basically coming from idautils, hiding so much logic behind the CPU object instance. It will hide all the necessary API calls in order to conveniently access the register. So here, if I run it, let's print it as hex. We should match the same value here. So it is F3F3C, which is here. And of course, we can change the value as well. So that's another convenience. idautils.cpu.ax equals 123, for example. And we can see here the value has been changed. And another utility that we very useful inside idautils is the procregs. It's very useful for instruction decoding, as we will see in future episodes. So this is the idautils. It also has PE-util, helps you retrieve the PE header that is inside the database in case you don't have access to the input file anymore. So it knows internal nodes how to access the stuff that the file loader put into the database. Anyway, this is for future topics. So that's idautils. And finally, we have init. Init is an initialization script invoked by IDAPython plugin itself. And so I think now we covered the stuff that are installed. So the last piece is the actual plugin binary itself. So in the Python folder, we have the support modules, and in the plugins, we do have the two plugins, IDAPython 3 and IDAPython 3_64, which correspond to IDA.exe and IDA64.exe. So this is the actual native plugin. Now let's take a look at that plugin itself, explain how that native plugin works. So I did clone the plugin into the SDK inside IDAPython folder. So this is my copy of that open source plugin. Now the main source file for the plugin is called idapython.cpp. That's the main plugin code for as a regular plugin for IDA. It does include python.h, so this is totally expected since we know it's gonna be using the CPython API, so that's a good indication. It does include some headers that are necessary to integrate with IDA. So after all, this is an IDA plugin and also a Python host. It does use helper py wraps helper file. We'll talk more about py wraps in a bit. But these contain lots of helpers, so you don't directly have to call Python C API, you call those helper methods. Since this is a plugin, we can expect to find at the bottom of the file the plugin descriptor. So here plugin T, plugin, that's what we should be exporting as a plugin, and so on. You can see most important plugin flags are the plugin fix. So this makes it load as early as possible. Plugin hide, IDAPython doesn't want to show any plugin menu items. Plugin multi is for recent plugins. So since IDA became purely 64-bit binary, and then I think since 7.0 or something, and so on. So what is important at least is the init, and we can see the init here, which creates a new instance of the plugin. And I'm sure this will be inheriting, as we can see, from plug mode T. If you've written plugins before, that would be like something you're familiar with. So here, if we look at the plugin, we see every IDA plugin should be inheriting from plug mode T. Let's jump to the init method. So we will see the first thing it does, it reads a config file. Now it's a good opportunity to show you that where is that config file. So same story, if we go to the IDA installation location, we will see a folder called CFG, and here we should find IDAPython. So when we install IDA, it also drops a config file for IDAPython. And there are some variables here, configurations that are picked up by the plugin, changes the behavior slightly and so on. So IDAPython starts by reading the config file. Among other things, it will initialize the Python C API. Here we can see it's preparing some Python statements with those variables, and it's passing what it read from the config file. And then it's running it as a script. So apparently it's injecting code into the Python global environment. And as we can see here, is then it's saying run init. Let's take a look at run init. It's trying to get its Python path and formulating where's the init script. And it's gonna call the init.py. Here is the init script. It's making the full path, building it to point to full path init.py, and init.py is executed. Now we can go back to init.py. Now we know how init.py is invoked. So let's revisit it again. So when the plugin is loaded as early as possible, it will IDA will call the plugins as init. IDAPython as a plugin, its init method initializes C API, and then it will be calling the init script. So what happens when the native plugin is initializing and then calls the init.py? So it calls init.py to continue doing some initialization. So one of the important things we will see here is it does create a class for stdout where it overrides the write method and redirects it to kernwin.msg. In reality, if we want to print a message in IDA, we think that we are doing it naturally, like print hello, for example. But the way this works is because of the output redirection. So, but in reality, we can say idapi.message hello. And that's what you would do in the SDK if you're writing C code. If you want to print a message in the output window in IDA, you will have to say message and a message. In Python, it has been redirected to so print can basically indirectly call the message function. And that logic, now you understand how it works and where from. It's in the init script. And we will see how actually the hooks are installed. So if we follow the use of that class, we'll see here the instance is being created, and that's how we could redirect input output in Python. Here the banner, we see the banner and whatnot. When we started IDA, it comes from init.py. And here we can see those global variables. Those have been injected from the plugin. If you recall, the config file from the plugin was, let's see, run init. So here, if you recall, these have been introduced, then init has been called, run init. So those global variables, if we go back to init, we don't find any assignment at all. So if you like, where are those assigned? They're not assigned through direct Python code or a Python script. They are injected from the native code. So these as well, that's how those config values influence the behavior of the plugin. For example, hey, do you want me to automatically import certain things? If that configuration value is set, then by default, certain imports will be available. This is just like a compatibility switch, for example. Another important aspect of the init script is this one, the IDAPython RC.py. The goal of this one is to give you a chance to run Python code as early as possible. So how early? It's as early as the plugin initializes. And how early does the plugin initialize? Since we specified for the plugin to be a plugin fix, this will be as early as possible. So we can read the documentation for this one. So the plugin fix, load plugin when IDA starts and keep it until IDA exits. And that's basically a way to have a plugin that can be loaded as soon as possible in order to fix IDA, so to say. It's not necessarily always like fixing IDA, could be adding very early on functionality. So in this case, we want IDAPython to be available as soon as possible, even if we are not working with any database. So if you run IDA with no parameters and no database, you will still see that we have Python available. That's because of the plugin fix flag. If we don't have that flag, it will load like a regular plugin available when database is available and unloaded when it's not. So here we're making it a plugin that stays forever until IDA exits. That's why if we pollute the global namespace in Python and let's say we import a package or something, even if you change the sources of the package, it will not be reflected since it's still the same environment. So here, let's say if we run Python on its own and import, let's say, OS, and change stuff in the OS source code, now it will not be reflected until we reopen the host or Python, for example. And so this is important to keep in mind, that because it's loaded when IDA starts and it will unload when IDA finishes, you might observe certain things are permanent. And there are ways to overcome that. For example, we'll have to use some kind of a reloading mechanism to reload modules and overcome that. And there are nice convenient plugins that help you work with such scenarios. Such a thing is IDAQ scripts. You might see it in another episode I've done already. So that's the plugin mainly, and we were saying it invokes the init RC as early as possible. Where can we put our init RC file? Here we can see how the init script is looking for it, and we can evaluate it in IDA if we wish. So we can copy this, for example, and evaluate it. I know where it will go, but I'm just showing you how things work. So here IDA API dot get IDA user directory, append to it this one, and let's print this. So it's expected to be in your local in your home directory. If you're on Linux, it's going to be a different path, and same on Mac. So that's where the init.py loads the user script as early as possible. Should be called init.python RC. So Control O, and that's what I put some stuff here just to see if it's working. Save it, and I can run either with or without arguments, and I will see that output. So here, let's say without any database or arguments, and that's the init. That's as soon as possible. Let me see if there's more stuff to cover real quick here in the IDAPython. Most of the things, of course, are support stuff and so on. The way IDAPython works is it registers an external language. So it becomes available through two ways. First way is through the CLI. That's a different API mechanism in order to have this kind of thing. So you don't have to have scripting support. So you can have your own custom interpreter here. It's called CLI_T, but scripting support is independent from the prompt here. So the external language is the mechanism that we can use to augment IDA. And using that mechanism, we introduced Python scripting. But you can use external language mechanism to add any language like JavaScript or any other language that you can host programmatically. Any scripting language, custom language, it doesn't matter. expert.hpp external lang. So if we look at the SDK, the external language is the mechanism we need to implement, provide a compile expression method, compile file, call a function in a generic manner. So any scripting language that you can write that bridge, you can bring it to IDA. The common factor that bridges all languages to something that IDA UI and IDA kernel understands is IDC. So IDAPython itself has to use the SDK and be that bridge and convert Python objects to IDC objects so the kernel can consume them and so on and so on. We don't have to be concerned about these details, but that's the lowest explanation I can give you about IDAPython. So that was basically another aspect of IDAPython, and we should see here the CLIT. So the CLIT is the other mechanism that lets us register prompt here. So the CLI is one mechanism, and the language itself that we can see all the registered language, for example, through the script command or the snippet window. And all the registered language independent of the CLI here, or the external languages will show here in the dropdown. And these come from external languages, this comes from CLI_T. Other stuff I'd like to mention in IDAPython. So we covered the main IDAPython source file, the CPP file here. And there are other helper things worthwhile mentioning inside the py wraps. So py wraps, we see like py bytes, py, etc. That's something I devised a long time ago as well to help me quickly prototype. These will not be available directly to you in the IDA installation folder. These are the things that get injected into IDA _ the corresponding things. So for example, let's say py expression is going to be injected inside IDA _ expression. So here we put some special markers picked up by the building script and whatnot to help us inject some code, handwritten code, into the SWIG generated files. So in the py wraps is where the manual intervention takes place, and we have a chance to either slightly modify an existing API or completely re-expose an API in a higher level, cleaner, more Pythonic way. Such a very evident example would be, let's say, all the things, UI things. For example, the ask form. This one I designed a long time ago. Working with forms in IDA in the SDK is complicated. So I took the chance to rewrap it manually in such a way to make it easy to write forms. And here we see so many different higher level wrapping, introducing new concepts in order to use an API very conveniently. So ask using form is an example. We can see choosers is another example. And of course, there are C code and Python code counterparts as well. So the py choose HPP is the Python C helper that we write. And then we have to expose another Python equivalent. And that's, for example, a Python chooser. We will have future episodes specifically for different UI and other API facilities. But that's it for this episode. I hope you learned a lot about the internals of IDAPython. And in the future, we will be discussing various topics, how to do this and that, and so on. So good luck, and see you next time.